In this module, we're going to talk about the nomenclature of acids. Our objective is to learn how to name both binary and oxyacids according to the IUPAC rules. First, we're going to look at naming binary acids. These acids are named binary because they contain two elements, although they may contain more than two atoms. These are substances that yield hydrogen ions or hydronium ions when they're dissolved in water. And to name them as acids, we simply add hydro as a prefix and ic as an acid. Let's look at a couple of examples. For the acid formed from fluorine, which is HF, we have hydro, fluor for the fluorine, ic, acid. We can do the same thing for sulfur. It becomes an acid when we have hydrogens added at the beginning, so we have the formula H2S. We add hydro as a prefix, we have the name sulfur, and we add ic acid to the end. We can also look at the naming of oxyacids. It's a little bit more complicated, but there are still some systematic rules to help us learn how to name these compounds. A couple of oxyacids which you may be familiar with include sulfuric acid, or H2SO4, and nitric acid, or HNO3. So before we look at how we name the acids that we form from oxyanions, let's look back at the names of the oxyanions. We notice there's a lot of similarities in the names of these anions. For example, we have nitrate and nitrite, chlorate and chlorite. And there's actually a trend in how we name these compounds. If we have a compound with some number of oxygens that has the AT ending, we just memorize that name. Then anything that has the ITE ending is going to have one less oxygen than the ATE compound. For the hypoite compound, it will have two less oxygens. And the per-ate compound has one more oxygen than the ATE compound. Let's look at an example with sulfate. We know the formula of sulfate is SO4 2-. When I want to name the other oxyanions, all I have to remember is the sulfate name and formula. Then, if I go to one less oxygen, where I have SO3, it's now sulfite with an ITE ending. The ITE ending means that it has one less oxygen than sulfate. It doesn't designate a specific number of oxygen atoms. Notice that both of these have the same charge. We can also go one farther where we have two less oxygens than the ATE compound, and we get hyposulfite. So we still have the same base name with the sulf, but we have hypo and ite added on. We also see the same charge on this anion. On the other end, we can add an oxygen and get to persulfate. So we have SO5 and again a 2- charge, and one more oxygen than the sulfate compound. Note that we can name ions this way for all of our oxyanions. However, that doesn't mean that these substances are commonly found either as the anion with a partnered cation or as an oxyacid. Now we can look at how we name the acids based on the name of the anion. Any anion that has the hypo and the ite in the name will be named hypo, and the end of the acid name will be OUS. If we have the ITE ending on the anion, the ending on the acid is OUS as well. For the ATE ending, we have ic acid, and for per and ATE ending, we have per-ic acid. So let's look at an example of how we would use this. So for sulfuric acid, this came from the ATE ion, or sulfate, and so it is H2SO4. If I go down one oxygen to the sulfite ion, then what I see is I have sulfurous acid. This was formed from the SO3 2- ion. One more oxygen down, I go to hyposulfurous acid. Again, I have SO2 2- as the anion and H2SO2 as the acid. If I go to the persulfate ion, the name of the acid is going to be persulfuric acid. So we have H2SO5, which was formed in the SO5 2- ion. Let's look at an example of the IUPAC name for HI. The name of that would be hydroiodic acid. This is a binary acid that's formed from a hydrogen and the iodine ion. So we simply add hydro at the beginning and ic acid at the end. Let's look at an example with an oxyanion. Here we have the PO3 3- ion. So the name will be phosphorus acid, because if we look at the name of the ion, PO3 3-, we notice that it has one less oxygen than PO4 3-, which is named phosphate. So the name of this ion is phosphite, because we have one less oxygen than the ATE compound. And when the name of the anion ends in ITE, the name of the acid ends in OUS. Now that we've looked how to name a variety of compounds, now we're going to look at calculating the molar mass of those compounds.